Alright, this is the second part of topic 18 notes. We are starting with section 18.5 and you do not want to do this without having a calculator or another technology piece that randomly generates numbers. So if you don't have that, please pause the video and go find one before you continue on. Please make sure that you're actually doing this with me as opposed to just listening to what I do. The practice is what you need in order to be successful. So, in section 18.5, we talk about using random numbers to simulate probabilities. This example says that a quarterback usually completes 60% of his passes, and we are asked to conduct a simulation of 20 passes and record your results. So if you think about 60% as a fraction, 60% equals 60 over 100, and both of those are divisible by 20, so that equals 3/5. So what we're going to do is we are going to assign numbers 1 through 5 because my denominator is 5. So I'm going to let 1, 2, and 3 represent completions, and I'm going to let 4 and 5 represent incomplete passes. So you can see that if you have 3 out of 5, that's 60%, so 60% completions, 3/5. Now what you're going to do is you're going to randomly generate 20 numbers from 1 to 5 and record the results. So I'm going to make a table here. Complete passes and incomplete passes. And what I would like for you to do is randomly generate your own numbers. I am going to walk you through mine. So I have my calculator out and I'm going to probability and then the RANDI, random integer, and I'm going to type in from 1 to 5. Now if you don't know what I'm doing right now, that means that you didn't understand earlier lessons that you need to go back and review. So I'm going to hit enter 20 times and record the results. You should record your own results. I will tell you what I get. So I get a 2, so I'm going to put a tick mark in complete. Remember, 1, 2, and 3 represent complete passes. 4 and 5 represent incomplete passes. My next number is a 1, so that's complete. Then I got a 4, that's incomplete. A 3 is complete. 2 is complete. A 5 is an incomplete pass. 1 is complete, so that's 5 there. Another 1. Another 1. Another 1. Oh my goodness, another 1. A 4. So that's incomplete. A 2 is complete. A 1 is complete. A 5 is incomplete. A 1 is complete. A 3 is complete. Another 3 is complete. Another 3 is complete. So far I have 19. And here's my 20th. I got a 1. So that represents the passes. So if I make if I do a experimental probability of this, I see that I have completed 16 out of 20 passes. And if you do the calculation there, 16 divided by 20 is 0.8. So in my experiment, he completed 80% of his passes. So it was higher than expected. Let's move on to the next problem. It says on a multiple choice test, each of the questions has 4 choices. There is only one correct answer for each question, and there are 15 questions. Which of the following can be used to simulate the situation? So the first thing I need to identify is the probability of getting something correct. So I have 4 choices, and there's one correct answer. So the probability of getting it right is 1/4. That's the important piece. So should I use numbers 1 to 4 and assign 1 as correct, 2, 3, 4 as incorrect? That would work. 1 out of 4 is correct. Using numbers 1 to 10, assign 1 through 4 as correct and 5 through 10 as incorrect. So if I did that, that would be 4 out of 10. That does not equal 1/4, so this would not be a good way to simulate the situation. The next one, use 1 to 15, assign 1 to 5 as correct and 6 to 15 as incorrect. So that would be 5 out of 15, which simplifies to 1 out of 3, which is obviously not equivalent to 1/4. So that would not work. If you use numbers 1 to 100, assign 1 to 15 as correct and 16 to 100 is incorrect. That would be 15 hundredths. That is not equivalent to 1/4, so that would not work. The last one, using numbers 1 to 100, assign 1 to 25 as correct. So that would be 25 out of 100 correct. That simplifies to 1/4, so this one would work. So you have to understand which ones work and why. That was an abbreviated version of 18.5, and now we're moving on to 18.6 on the next page. I really enjoy 18.6. It is using your calculator to randomly generate numbers to simulate some more ideas, but these are a little bit more complex than 18.5. So an example in 18.6 is a gardener plants several seeds into each hole. And you can see an example like this on digits if this is not enough to help you understand it. Each seed has 30% chance of sprouting. Use random numbers to simulate planting 5 seeds in each of 24 holes. Okay, so the 24 holes is the number of times we're going to do this, and 5 seeds in each hole means that we're going to have 5 numbers in each of the 24. How many simulated seeds sprout in each hole? Make a frequency table of your results. So the simulation explanation is the first thing I'm going to do is find the probabilities for each outcome. So the probability for each outcome is 30% chance of sprouting. So that means I have 3 out of 10 sprouting. Assign numbers to each outcome based on probability. So if 3 out of 10 sprout, I'm going to say that numbers 1, 2, and 3 represent sprouts. Which means 4 through 10 represent seeds that don't sprout. Okay, and then we're going to use a random number generator to simulate planting the seeds into 24 holes. Now, it's going to be hard for me to fit all of this in with my writing utensil that I'm using, so just bear with me. Notice that my table has 24 slots in it. Those represent the 24 holes. And I am going to plant 5 seeds in each hole, and I'm going to see which seeds sprout. So if you generate your numbers using your random number generator. Please do your own, but I'm going to walk through mine. You go to your probability in the random integer generator. You're going to have it choose numbers from 1 through 10. So I'm doing that on my calculator right now, setting that up. And then I'm going to do 5 different seeds in the first hole. So I'm going to randomly generate 5 numbers and write them in my first hole. So I got a 1, a 2, a 9, a 3, and a 4. That's what my calculator did for me. So in my first hole, I can see that I have a 1, a 2, and a 3 that sprouted, so 3 of the seedlings sprouted. The 9 and the 4 represent seeds that didn't sprout. So I'm going to continue this simulation, writing 5 seeds in each of the holes. So I got 7, 9, 8, 2, and 9, and I keep going. So what I'm going to do is I'm going to pause the video because you don't need to listen to me writing all these down, and then I will come back and explain what this means. What you should do is use your random number generator and fill in your table. Okay, so that took quite a while. Now that I have all my numbers involved, I'm going to take a look at how many sprouted in each hole and make a frequency table. So you can see the frequency table in step 4 there. So I'm going to see how many seeds sprouted in each hole. So if you look at the first hole, I have 1, 2, 9, 3, and 4. 1, 2, and 3, sorry about that, 1, 2, and 3 seeded. So that had 3 seeds. So I put a little tick mark. In the next one down, I have 10, 5, 6, 8, and 10. So none of those sprouted. So I have a 0 there. So I put a tick mark here. 8, 3, 7, 5, 7 only has 1 that sprouts, the 3. So that's a tick mark under the 1. 1, 10, 2, 6, and 8 only have 2 there. So I put a tick mark under the 2. Now I am moving over to this column. 7, 9, 8, 2, 9 has 1. So I put a tick mark under the 1. 3, 10, 8, 3, 3 have 3 that sprout. So I put a tick mark there. 4, 9, 8, 5, 3 has 1. So I put a tick mark under the 1. 3, 10, 4, 4, 8 has 1. Next column, 3, 5, 9, 10, 7 has 1. 5, 1, 1, 9, 6 has 2. 6, 1, 6, 7, 7 has 1. 3, 1, 4, 5, 7 has 2. Next column, 3, 8, 4, 7, 5 has 1. 1, 1, 8, 2, 8 has 3. 8, 8, 3, 3, 6 has 2. 8, 6, 2, 6, 2 has 2. Next column, I have 7, 6, 9, 6, 6, that's 0. 9, 4, 5, 2, 9 has 1. 3, 7, 1, 6, 9 has 2. 7, 3, 9, 10, 1 has 2. 6, 7, 6, 7, 6 has 0. 3, 4, 7, 6, 1 has 2. 10, 2, 7, 7, 7 has 1. And 3, 5, 8, 8, 8 has 1. So in my simulation, I didn't have any that had 4 sprouts, nor did I have any have 5 sprouts. 3 of the holes had 0 sprouts. 3 had 3 sprouts. 10 of them had 1 sprout. And 8 of them had 2 sprouts. So that's how you do that kind of problem. You probably want to listen to that again just to make sure that you understand all of that work. Alright, let's take a look at the last example, and we're going to do this very similarly to the previous example. It says about 44% of the people in the United States have type O blood. Use a simulation to estimate the probability that exactly 2 of the next 3 blood donors at a hospital have type O blood. So, the way we're going to set this up, we are going to test 3 people at random for type O blood. So, each of the boxes is going to be 3 people's test. Now we need to assign the numbers to the outcomes. So we have 44% given to us, which means 44 out of 100. If you simplify that, that's 22 out of 50. Simplify that again, and that's 11 out of 25. So, I'm going to assign numbers 1 to 25, where 1 through 11 have type O blood, which means 12 through 25 don't have type O blood. Again, one trial is testing 3 people for type O blood. And we are going to, blood. We are going to run many trials. So I'm just picking a random number, 50, that's many trials. And then we're going to analyze the results. So what we need to do is grab our calculators and do the random integer generator. And we are going to have numbers 1 through 25. So I'm setting that up on my calculator right now. And then I'm going to randomly generate 3 numbers for each box. I'm going to do 50 trials. So again, I highly recommend that you create your own table so that you get practice using that generator. Here are my results. So what I'm going to look for, okay, is to analyze the results and remember the question. Estimate the probability that exactly 2 of the 3 have type O blood. So what I'm going to do is I'm going to circle the trials that have 2 out of the 3 having type O blood. So I'm looking for numbers 1 through 11, and I need 2 of them in each box. So I have one here, another here, and I will pause the video and circle all the ones that have exactly 2 of the 3 blood donors having type O blood. Okay, so those are all the ones that have 2 out of the 3 people having type O blood. When I count them up, I get 18 circles, so 18 out of the 50 had 2 of the 3 people having type O blood. If I convert that to a percent, that's 36%. So the probability that exactly 2 of the next 3 blood donors at the hospital have type O blood is 36% according to my experimental probability. That sums up topic 18. You should make sure that you do the digits homework and watch any videos that you think would be beneficial to help you understand the material better. Ask me any questions that you have.